everyone. We are back again to continue from where we stopped. We are here with lecture 2 of the basic algebra. And I hope last time you had an interesting time, and we will be building in from there. It was very marvelous that you did. You listened to that video and then you had a good understanding. Let's see what the good Lord bring today. But before we continue, we need to revise with you what has been learned already. Last time we established 4 basic facts. We said that whenever a number plus another one equal to an answer, it is an established fact that one of the numbers is the answer, take away the other added. That one is fully established in our lecture 1 of the basic algebra. So if you haven't watched that lecture 1, you go for lecture 1 and before you come and continue from here. So from there we said that the box, if I'm giving box plus 3 equal to 7, I could equally use that idea to look for a number I cannot see in the work. So we came out with this algebra. And then the second situation was like, if you have 8 take away 3 equal to 5, if 2 numbers subtract to give you an answer, the number in front is always equal to the answer plus the subtracting number. The number being deducted, you add it to the answer and it will be equal to the number from which we are deducting something. So that one to give us a clear pathway different from guesswork with which we can be using to come up with unknown numbers. So we did that and use it to find a number in a box. In other words, they want you to find a number in the box, and primary school will say, use your head to fix the number. And we think that method is not very efficient because in the last video we proved why it is not. When the numbers are so big or when they are fractions or when they are decimals, you cannot proceed like that. You need an efficient way. A mathematician came out with this way. So because of that, R and box are the same. They are just trying to say, in fact, what R is doing, they could equally have drawn a hand over there and they will say that a hand plus 3 equal to 5. In other words, the hand is covering the number. That's all that variables do in mathematics. So they ask that, find the number that I have covered with the hand. That's what you are doing. So you will say that, okay, hand, under the hand is equal to 5, take away 3. So under the hand, the number that the hand is trying to hide is actually a 2. And we all know that you need to add 2 to 3 before you make a 5. So all that these variables are doing is just hide the number, ask you that which number is supposed to be there, which number, that's all that they are doing. And you bear with me, it is easier to write X, Y, Z than to be drawing this hand. If you are not a visual artist, how will you be drawing this? I only use it here to demonstrate to you that this is what the variables are actually doing. Fine. So it was good we came out. So we came out with all these ideas that another way is there. Instead of using our head and fix the number that we have gotten. And there are 4 in levels. The one dealing with plus, the one dealing when the situation is a minus, the one dealing with when there is a times, and the one dealing with when there is a division. They are all different in a little way, but it is all about numbers and the way they behave. Now, if you've gotten this 4 down, we say that the story is not complete with 2 of the steps that have already been developed. The story with minus and division are not complete. Why are we saying that? We established down that whenever a number take away another one is equal to an answer, the 4th number is the answer plus the deducting number. Fine. But the question now is that if the box were not to be on the 8 and it were to be on the 3, what would have happened? Are we going to say that we are going to add the 8 to the 5? 8 plus 5 will never give you the 3 in a way. So in our 2 special cases, we are trying to put the box on the 3 and see how we will come up with the answer. So the idea with minus is not complete, and we want to complete it today with two special cases. So the story of subtraction and division are not complete, and they are our target. So we said that idea, it is only applicable when the front number is the one you are looking for. In that case, you go and add the subtracting number to the answer. But the opposite is not true. If it were the 3 you are looking for, it is never true that 3 is equal to 5 plus 8. No. It's not. But the thing is the same with plus, but it's not the same with minus. After the situation of plus is complete, because whenever two numbers are to give you an answer, one of the numbers is the answer minus the deducting number. Whether it is the 4 you are looking for, you will just do it 7 minus 3. Or if it is the 3 you are looking for, you will start say 3 is equal to 7 minus 4. That one is going to minus in two situations. And none of them changed. But the situation of the minus did not give us that liberty. So we want to complete the full story here. We look at this situation carefully, that if I'm looking for this 3, it's like when mathematicians sit down and they observe situation carefully, they come out with a formula, a strategy, or a procedure. What they observe here is that keep the 3 there, and this is the idea established. The minus here is actually for the 3 and not for the 8. In other words, it is the 3 that is being deducted. So if we are doing anything at all, if we are to transport the 8 away, we should not forget to keep the minus remaining with the 3. So the idea established is that to the left of every number, the sign that is in front of it is for that number. So 8. To the left of the 8, there is no sign. So we take it that it is positive 8. It is a positive 8. To the left of the 3 is minus, so it is a minus 3. This is the first understanding you have to get. Good. Now, this is a positive 8. Whenever you are sending a positive like this go to the other side where the answer is located, it is established that keep the sign of the 3 remaining with it, because to the left of the 3 is a minus. So when we go over the equal to sign, whoever is there, that is the host, you keep it there like that without, and it must come first. Whether it is a small baby or this thing, it is there before you are coming. So the host must be there, whether it is small or big. It must be in front. The one that is coming to the host must always take second position. If the number was having a plus in front of it whilst going there, it is now going to have minus in front of it. So plus 8 becoming minus 8 by going to where the answer is. By so when they got minus 3 equals to, we know that 5 minus 8 is actually negative 3. It's not 3. It's not just 3. Because you see 8 is bigger than a 5. So this is negative 3. It was okay. Yeah, the idea is very clear, because here is negative 3 and here is negative 2, and that makes sense. Okay, but it is not a negative 3 that we are looking for. We are looking for the 3 without the negative. Without the negative. So how do we do that? How do we take away the negative? It is something we know again in mathematics that every negative number can be written as the product of negative 1 and a positive of that number. Negative 1 times 10 is negative 10. Negative 1 times 50, negative 50. Negative 1 times... No, every negative number can be written as negative 1 multiplying a positive part of the number. Don't forget, if they were all negative, that negative times negative will be positive. So one of them will be negative while the other is positive. So using that idea, we can use the idea here that it seems that we can write negative 3 as negative 1 times 3, because that's a negative number, and negative 1 times positive 3 will give you a negative 3. Then we go ahead and get this. From here, we are going to invoke this idea that we have established in our lecture 1. Whenever two numbers times themselves to give you an answer, one of the numbers is the answer divided by the other multiplier. So these two things are timesing and give negative 3. If I'm looking for one of them is equal to the answer divided by the other multiplier. So I think that if I'm looking for the 3, since it multiplied this number to give that, I could actually say the 3 is equal to negative 3 divided by negative 1, according to this rule that was established in the last lecture. So by so doing, if a calculator or ordinary this thing will tell you that a negative divided by negative, the negatives will cancel themselves away. In that case, 3 is equal to 3. We come up with a 3, but through some mathematical tour de force, as they say it in French, tour de force. I mean, we suffered that, or we passed through some hectic moment to come up with a rule. But the rule is quite clear. Try to go over it again and again, and you will get the rule without mistake. That every number, first of all, establish the idea that to the left of every number, if there is no sign at all, it is a positive number. But if a sign is there like negative, then the negative is for that number to which it is to the left of. So in the series, this 8 was given originally without any plus here, but as I see that there was nothing in front of it, I take it that it is positive 8. The 3, if you go to the left of the 3, is where the minus is. So the minus is for the 3. The same way the 5 is actually positive 5, because to the left of the 5, there is no sign. Now, after you got that first thing, then you go to the second level. Whenever a number which is positive, we establish where it will be positive and where it will be negative. Whenever a number which is positive will cross the equal to sign, this very sign, and go to the host that was there, first of all, it will take a second position. It will not take a first position. When it gets there, it is positive. Then by getting there, it will take negative of that number. Don't forget, the other rule that was half rule to this also did the same thing. When the thing was a negative 3, by the time it go to where the 5 was, it became plus 3. Now that we are at where we are interested in moving the 8 rather, be positive 8, by the time it went there, it became minus 8. So the idea is coming up clearly here. If you are minus and you go over, you become plus. If you are plus already before going over the equal to sign, you become a minus. So by so we keep negative 3 here, and this is 5 take away the 8 that was coming. So by doing so, we know that 5 minus 8 is actually negative 3. Now we have negative 3 is equal to negative 3, but our target is to do away with the negative. We want 3, pure 3, not negative 3. So we use the idea that we know that every negative number in the world can be written as negative 1 multiplying positive of that number. So negative 1 times 3 is equal to negative 3. And when we do, we invoke this idea that whenever two numbers times to give you an answer, one of the numbers is the answer divided by the other multiplier. So using that idea, I managed to say that negative 1 times 3 is equal to negative 2. So I'm looking for the 3. So 3 is equal to the answer negative 3 divided by negative 1. And the calculator or ordinary cancellation will tell you that the negatives will cancel away. So 3 is equal to 3. If we keep this idea carefully, that means we can apply it here. We can apply it here and say that, okay, it seems that we can, since we want to send the 8 and we know that it's positive 8, don't forget, in front of it there's no number. To the left of the 8 there is no sign. That means it is positive 8. When the positive 8 you go to where the 5 is, then we will keep the negative attached to the box. Keep the negative attached to the box whilst you Whilst you keep the 5 here and then do minus 8. Being plus 8, it became minus 8. Getting to the other side. So now the situation is negative box equal to negative 3. Okay, and you understand the reason why we don't want negative to attach to the box. You see, here it was a pure number, so you saw it. But here, whatever number that is in this box, if you say negative of it, we can write it as negative 1 multiplying positive of the box. And the algebra continues from here, that anytime two numbers multiply to give you an answer, one of the numbers is the answer divided by the other multiplier. And ordinary cancellation will tell you that the number that is supposed to be in this box is actually a 3. This completes the story of the negative. Mathematics sat down and came out with a clear path that will complete the story of negative. So here, the idea remains the same. 8 is the one going away, and to the left of it there is no sign. It is a positive 8. So I'll keep the negative attached to the R because it is the negative is to the left of the R, so it is for the R. So negative R is equal to 5 minus 8. And so negative R equal to negative 3. And we don't want the negative to be attached to the R. But if it finally ends up attached to the answer or this side, we don't care. But to a variable, we don't want a negative attached. So we know that every negative number is negative 1 multiplied by positive of that number. And don't forget, I didn't bring the times because I said, why I told you why we will not bring times. And equal to negative 3. If two numbers multiply to give you an answer, one of the numbers is equal to the answer divided by the other multiplier. Ordinary cancellation will actually give you that the R number is actually 3. Beautiful, beautiful, beautiful. The method for coming up with the answer with regard to plus or minus has been fully established. We believe that this method or this means of arriving at the answer is bigger. Is a big embodiment of both the plus and the minus are together in this. Yes. Because at the time we are dealing with our two numbers are to give you an answer. One of the numbers is the answer minus the other. Then don't forget, all of them are positive numbers. The 4 is positive 4. The 3 is positive 3. So any of them that want to go over will actually assume minus at the other side. But in this situation, it's like a number that is plus is in the work and minus is in the work. That is why at the time the minus number is going over, it will go and plus over there. But when the plus number is the one to go over, then it will take to minus. Nice. So before we work some other, or maybe we can actually make some example before we come and complete the story of the division. Maybe you give me maybe no, I want the k to be second. So maybe 13 minus k. The answer is maybe 7. They said to find the number that is k. Don't forget, so that the thing is like a hand. 13 minus a hand is equal to 3. Equal to 7. To make up this, I will use the idea already established that to the left of this 30 is positive 30. So the minus here is for the k because it is at the left of the k. So if 30 want to go over, I must keep the minus attached to the k because it is for the k. Whilst I go over and write the answer first, before the one coming over to where that answer is here will now take a change. Minus k equal to negative 6. Since we don't want k attached to the variable, we will do it, and negative 1 times k will give negative 6. For that matter, two numbers multiplied to give you an answer. One of the numbers is equal to the answer divided by the other multiplier. If you do your cancellation, k is the number 6. And we are all convinced that 13 minus 6 is actually a 7. That's nice and beautiful. Now, we have been working with this system for now, that you may not always get an answer as a full whole number. There can be some fraction or something. All that, the formula remains the same. You must apply the formulas of mathematics very rigidly. The formulas of mathematics are not something that can be easily tampered with. They are very rigid. That's why you have to get a clear understanding of them, and you can now proceed. Now, we want to proceed here and come up with a story about the division. That the division too is not complete. The division is not complete. Look at the situation of 18 divided by 6 equal to 3. We've already learned from lecture 1 that at this particular level, we just need the 6 to multiply the 3 and to give you the 18. So if somebody is hiding the 18 using box, I could just come out with the 18 by saying the box is equal to 3 times 6. And the number that will be in the box will come out clearly. But we are now interested in, if somebody put the box on the 6 instead of on the 18, what will happen? So in this particular case, we decide to fix the box on the 6 and try to find it, come out with the 6, and see what procedure will come out with it. Because when the box was at the top here, the thing was easy. You just use the divisor to multiply the answer, and you get your number in the box. But now the box is on the 6. We must come out with 6. The formula didn't go straightforward or parallel as you guess. If you're looking for the 18, you do 6 times 3. But if you're looking for the 6, you can never do 18 times 6 times 3. You cannot do 18 times 3. You will not make that much mark. So we decide to develop an algebra, a means of solving a mathematics or doing a mathematics. We give it a name called algebra. Algebra is a name of one Persian mathematician who lived, I think, in the 4th century. He has his name is actually algebraic also, and he has done a lot of things in mathematics. So they put his name on a way of doing mathematics. So we have to come up with an algebra, a way to develop or come up with the number in this box. When we study critically, realize that f for the 18 is equal to 3 times 6, but the 6 is not equal to 3 times 18. No, it's not. So this is what they come out with, that even if the box happen to be this one, don't worry. All the time the rule is established that the 18 is supposed to be equal to 3 times 6. That one is a fact. Since you are interested in the 6, then consider the idea as if two numbers multiplied to give an answer written in the opposite. Written with the 2 times 5 rather here and the 10 rather here. It doesn't make any difference. Use the idea backward like this. Anytime two numbers multiply to give you an answer, one of the numbers is the answer divided by the other multiplier. So 3 times 6 give 18. So the answer happens to be at this side, but it doesn't matter. If I'm looking for the 6, I can say that this 18 divided by 3 will give me 6. And it is a fact. So I will use that idea, but this written in some opposite way. 18, if you divide it by 3, you will actually get 6. By dividing 3 here 1, 3 here 6, you will come out as 6 is equal to 6. Or if you change the position of the 6, you will still say 6 is equal to 6, because they are all 6. But the reason why I write this level is that at the end, you will get the box rather here and the number here. But change the position of the two and you are there. Now, so with that same ideology, I know that 18 must be written equal to 3 times box. because the box is a divisor. So by all means, it must multiply the 3 to deliver the 8. At this level, I'll use the idea of two numbers multiply themselves to give an answer, despite the two numbers multiplying at this side. If 3 times some number gives 18, then that number must be equal to 18 divided by 3. 18 divided by 3 equals to box. So if you do the cancellation, 3 here 1 and 3 here 6. 6 is equal to box. This is what I'm talking about. But because whatever is here is like equal to whatever is here. So whether you change their position or not, they are equal to themselves. So that's why you say, or box is equal to 6. In other words, change their position. After all, whatever is here is the same thing here. See that when they were 6 and 6, when you change their position, they are the same. The same thing that happened here. So the idea is quite established that whatever is at the down there, whether it is a variable or a real number, the idea is clear. When a number divided by another equal to an answer, the number being divided, called the dividend, is always equal to the answer times the divisor. All the time, whether variable or number. Then, finally, to make out the answer, we know 18 over 3 will give us the W. By doing your cancellation of 3 here 1, 3 here 6, 6 is equal to W, or W equals to 6. Every time in name. This is 30 minutes. So we have added flesh to the bones. We started very basically with very fundamental, and now we've increased a bit. We've added a much more mature level of mathematical manipulation. If you keep this one together, you will realize that we just build upon what we started with. Mathematics, unlike any subject in the world, build on previous knowledge than any other subject known. This is why some people think math is difficult, because they don't go to study it from behind and go orderly. They want to jump into any chapter of the math and read. You cannot understand math that way. See that our lecture 2 was dependent on lecture 1, and 3 will depend on 2. So you must follow it orderly. Else, if you go and watch any of the videos like that, you may be confused and think that it was difficult at that level you are watching. But if you follow it orderly, you realize that you could do maths, and you also will not be scared about the subject. As people have been talking about, it will be some interesting field you would like to pursue and even go further in education in it. With that said, we will talk about some 2 examples with the idea that we've already established. Now, these 2 ideas, this one have embodied this and this together, that plus and minus are captured here. And then this one have captured the situation of times and division also. Because when a number is dividing, it goes to multiply. And if it is multiplying, it goes to divide. So division and multiplication are opposite of each other. A number engage multiplying. When you disengage it from here and go and engage it across the equal to sign, it will go and divide. A number engage here dividing. When you disengage it from here to go and engage it at the other side of the equal to, it will go there and go and multiply. Multiplication and division are opposite operations of each other. The same way, plus and minus are also opposite of each other. If a number is engaged in one side of the equal to sign, adding, by the time it goes across the other side, it will go and subtract. And if that another number is engaged here, rather subtracting, when it crosses to the other side, it will go and plus. It will go and add. So keep these rules to heart as we proceed to our lecture 3 of the basic algebra. Now, don't forget to subscribe, like, and share this video to other people that are writing examination and need to prepare themselves for the mathematics ahead. See you again in the basic algebra lecture 3.